Okay. Yes. Okay, well, first off, there will definitely, the question you have for today's in-class quiz, what is the evidence that primacy effects rely primarily on long-term memory and recency effects rely primarily on short-term memory? That is 100% guarantee that you will have a question about that research on the test. Now, I'm not going to go over it right now because I want you guys to do that for the in-class quiz. If you do the in-class quiz and you feel like you can't do it, then you can email me and I can answer it. But I really want you to try and get that one by yourself. I think you'll remember it better if you have to do it by yourself. Otherwise, let's see, go back to chapter 2. Okay, here's like a potential quiz question, a test question. We talked about earlier today the phenomenon that individuals from, for instance, Japan, they do not, when we would say like a word that contains the R sound, they actually do not hear the R sound. Apparently, they're more likely to hear it as like an L sound, for instance. It's not only individuals from Asian-speaking individuals. We as English-speaking individuals, we have similar things for languages where we can't distinguish between certain speech sounds from other language. So it's not just Asian-speaking countries; it's definitely English-speaking individuals as well. What is the name of the phenomenon that tries to explain why individuals from certain cultures are unable to perceive certain speech sounds from a different culture? I'll give you a clue. It's one of the words listed right there on chapter 2. Anyone know here?
Is it categorical perception?
It is categorical perception. Yeah. This is the idea. I think I mentioned in class, infants when they're born are actually infants in Japan, for instance, when they're born, they actually can tell the difference between la and ra sound, no problem. But as they get exposure to their language, they start to learn via exposure to their language that the ra sound, the ra, is not that important. It becomes obsolete to them. They start to form categories for those speech sounds that are important to them. And then the words, the letters, the speech sounds or the phonemes that are not important to them become obsolete. Categorical perception is kind of this idea that we form memories of the speech sounds, the phonemes that are most relevant in our language, and the speech sounds that are not relevant to our language become obsolete. We don't form memories. We don't form categories for them. So we talked about p versus k. So I'm staying with the speech questions. P versus k. That is those two speech sounds kind of differentiate the meaning of two words, pill versus kill. What is the name of a speech sound that distinguishes between the meaning of two different words, like p versus k? Those are examples of two what? Anyone know? It's another one of the words which is on here. Pa versus ka are examples of two different whats.
Phonemes.
Phonemes is correct. Yes. Okay, let's see. Maybe we should look at a speech spectrogram. Let's go ahead and do that. Why not? So remember that on a speech spectrogram, the x-axis is a unit of time, and the hertz is what is this? Hertz is a measure of what? It's not time. What is hertz a measure of? Does anyone know?
Frequency.
It is frequency. And when these are all different speech sounds. And when we're talking about frequency with speech sounds, that's basically different pitches. Might not realize it, but a lot of the different speech sounds that we make, the different speech sounds, one of the important, like you can see here, bab versus dad versus gag. Some of the important differences are the frequencies which are dominant in the speech spectrogram when we're saying it. So let's look at the questions here for this study guide. So the formants, where is it? Yeah, formants are basically what we are looking at in the spectrogram. Those frequencies where we see a lot of activity for a given word, those are formants. And so the dominant formants change for different words. So formant, I could ask you in the question, is formant a measure of, like duration? Is it a unit of time or is it a unit of frequency? You should know that formants are basically different frequencies in a speech sound. Okay, in the composite face task, what is the task that people are asked to perform in the composite face task?
Whether the the top and bottom match.
It's not whether the top and bottom match. You're on the right. You're getting warm, but it's not whether the top and bottom match. Keep going though.
Whether the top goes with the bottom.
Nope.
Oh.
You're warm, but you didn't get any warmer with that second guess.
Whether both of the bottoms are the same with two different tops.
Yeah, it's just the opposite. You're boiling hot, but so I'm just going to get you the rest of the way. It's whether the two top halves are the same or not. It's not, you're actually ignoring the bottom halves and you're only paying attention to the top halves. So for the composite task, you're looking at the two top halves of two different faces and you're asked to indicate whether the top halves are the same or not. In the composite face task, is the task tend to be harder when the faces are aligned or not aligned?
Aligned.
It is harder when they're aligned. Does anyone know why?
Because we want to put the T shape together on a face, so we assume that they're going to go together when they're put together.
Yeah, when they're aligned, we have a tendency to integrate the bottom half with the top half. But we need to ignore, we want to do our best to ignore the bottom half, and we're only trying to pay attention to the top half. And so the key word is probably interference. In the aligned condition, the bottom half of the face interferes with your perception of the top half of the face because of that holistic face perception, because of the T template. And so it's counterintuitive. A lot of people incorrectly put on the test that holistic face perception, that performance is easier in the aligned condition because it seems intuitive for some reason. But it's just the opposite. Performance is actually easier in the not aligned condition. Okay, let's move on. There's some other things that are hard in there, but you guys have to ask me about some of these. I'm not going to give everything away for free. Let's see. What's hard from chapter 3? In the Stroop task, what is the task that participants are asked to perform in the Stroop task? Anyone know this? What is the task that people are asked to perform in the Stroop task?
It's like you're supposed to say the word that it spells, not the color that the word is.
Just the opposite. It's just the opposite. But I'm glad you got the two important dimensions, but this is such a common mistake. And honestly, the way I would ask the question on the test, you would have to choose probably between those two options. So I'm glad you got it wrong now instead of on the test. The thing you're actually supposed to do is to say the color of the letters which compose the word while ignoring the tendency to want to read the word. In the incongruent task, it becomes difficult to say the color of the letters. Why is that? In the incongruent task, it's difficult to say the color of the letters correctly or quickly. Why is that? Why in the incongruent task is it hard to say the color of the letters? The color of the letters that compose the word. Why is that difficult?
Because the word would say like a different color and you'd want to say that color.
Yep, exactly. So it would be like the word blue written with red letters. if I gave you the word blue written in red letters, the correct answer would be red. That's what you're supposed to say. But you're constantly having to use your frontal lobe to inhibit the automatic response, the tendency to want to read the word. I already forget what I said. I think I said it's the word blue written in red letters. So you always want to say blue, even though the answer is red, because you've overlearned that automatic response to read words that you've seen. So that's what the Stroop task, the task is to say the letters that compose the word while ignoring what the word says. Okay. Maybe I should. What is the difference? So we did those search tasks, the pop out versus conjunction search tasks. Do you guys remember? Do you think you could describe the difference? I don't think you're going to be able to do it without a picture. So let's just go to a picture. This is in chapter 3. I think that's it. Yeah. Here we go. Right here. Is this a pop-out search or a conjunction search? Oh, by the way, you're supposed to find the horizontal 8, which is right here. Is this it is a conjunction search. Can you explain to me why?
It has both vertical and horizontal S's and 8s and S's.
Yeah, that's pretty darn close. So I'll get you the rest of the way there. Basically, this thing has 2 important properties. It has a shape property, and it also has its orientation. So its shape is 8, but it also has the orientation of horizontal. If you look at the distractors, those properties are shared. Those 2 properties are shared by many of the different distractors. For instance, there are many other 8s. So the shape is not unique to it because there are other 8s. So the shape of 8 is not unique to this. It is shared with other distractors. But neither is the property of horizontalness, because there are other shapes which are also horizontal. So none of the properties are unique to the target right here. Many of the distractors share the defining properties of the target. Contrasting that with this, let's go to this one. Oops. This is clearly a pop-out search. Can someone explain in words why this is a pop-out search?
Because they're all vertical and the others are all the same color.
Yeah, actually, the fact that they're vertical is not really even, it's not even that important of a thing. What really matters, but the color is definitely important. The target has one property which is completely unique to it, which it does not share with any of the targets, and that property is its color. So the defining, in a pop-out search, the target has a feature which is unique to it, which it does not share with any of the targets. In the conjunction search, the target does not have any unique properties. It's those properties in the pop-out in the conjunction search, the properties of the target are shared with at least one other distractor. Oh yeah, here's a good question. I could ask on, I don't want to show it to you because it's going to make it too easy. If I give you an individual with right hemisphere damage, and I have you do the line bisection task, how does a person with right hemisphere damage tend to perform on the line bisection task? If the person has neglect after right hemisphere damage, they have visual neglect after right hemisphere damage, how would they perform on the line bisection task? If you want, maybe draw a picture of a line and bisect it and then show it to me through the camera, if someone wants to answer. But I'm not going to give this one for free, so I want someone to try and get this. Maybe draw it on, if you have a pen or paper, draw it and then show it to the camera. Or I can do the same if no one can get it, I guess. But I really would rather someone else get it than me.
They would do poorly because they can't really see the left side of their visual field very well. So it might be like this, like uneven on one side or the other.
Yes, it's important though that they bisect the line. Would they bisect the line too far to the left or too far to the right?
Right.
Yes, too far to the right. because they miss the left side of the visual field. And so that causes them to think that the center of the object is actually further to the right. And you can see that. I took it away quickly because I didn't want to make it too easy with that statistics. Chapter 3, right here. And you can see them right here. Move your guys' pictures. This is what they do. So they're bisecting it too far to the right. And that's important because I could show you, for instance, the way I might do a question like this is I could show one answer would be like I would show this as the correct answer, but I could have as a wrong answer on the test, like the mirror image of this, where the line is bisected on the left. So I want to make sure that you know that if you have right hemisphere damage, you're more likely to bisect on the right side of the line. Let's see what else from chapter 3. Okay, yeah, here's a toughie, I think. Give me an example. This is an in-class quiz, though, so maybe it won't be too tough, hopefully. But I had 2 exclamation points here, meaning it's important. Give me a piece of evidence that supports the idea of late selection. I gave you 2 pieces of evidence that support the idea of late selection. Please give me.
My section one would be like being able to hear or like recognize that you heard your name in the ear that you're ignoring when you like are thinking back on it after hearing a series of things.
Yep. So you're shadowing in one ear. You're paying attention to this ear. In the ear that you're ignoring, someone says your name. And you have a tendency for that information, because it's meaningful to you, to pop out. And you're going to hear it even though you're ignoring that information. Can you give me an example of the type of information in this ear that you would not hear? If you're ignoring things in this ear, what is the type of information that you tend to not hear?
Things that like don't apply to you.
That's not false, but I need a little bit more information. I gave you a pretty specific example actually in class. I gave you one specific example. There's a specific type of meaning, a specific type of thing that when you were ignoring it, people almost never were able to detect it. It was a type.
Sorry, is it the language?
Yes, a language change, that's a type of meaning which is relevant to you, I guess. But for whatever reason, it's a type of meaning that you're not really paying attention to. When you're not paying attention to this ear, if the language changes from English to Spanish, you're not going to notice that change because that aspect of the meaning is not getting to your mind. You're filtering it out. That information is not reaching late processing. So that's the type of information that does not get to late processing. Only specific types of information seem to get to late processing. One of them would be your name, because that's particularly important to you. When someone says your name, it pops out. It's a type of word that has special meaning to you. I gave one other example. Let's go ahead and do both. What was the other example that I gave you in support of late selection?
The change in speaker, like if it was a man speaking and then it switches to another man speaking, it was harder to detect.
That is an important finding, but that was evidence for early selection. Because will someone remind me, what is the primary difference? What is the thing when you're detecting that the speaker's voice changed? What is the pitch? That's right. That's a sensory thing. That's a low-level type of information. And so that is actually evidence for early selection. When you're ignoring this ear, you can hear when the pitch changes because of early selection. Even when you're not paying attention, that information is still being processed about low-level information, of sensory information like the pitch of the speaker's voice. So that's evidence for early selection. That's an important finding, but it's not evidence for late selection.
I think the second piece of evidence you gave was the like if it was talking about a bank, like an ambiguous word, not ambiguous, I guess a word that has
that's it. Ambiguous is is definitely good.
So like it could be like a bank where you store your money, or a river bank. And so if it said like something about like water, then you say like what kind of bank were they talking about? You'd say, oh, like a river bank.
Yeah, so someone says something about a bank in the ear you're paying attention to. Something vague, ambiguous. You were standing next to the bank in the ear you're paying attention to. In the ear that you are ignoring, it'll say something about water or money. Whatever you hear about, whether it's water or money, will bias your interpretation of what you heard in the ear that you were paying attention to. That also supports late selection theories. So the thing that makes this kind of hard is some of the evidence supports early selection. Some of the evidence supports late selection. So I require you to just know both. You need to know all of the studies regarding early and late selection, but we've gone over the primary ones here now. I will probably ask you a question about the lines and beeps and pip and pop study, but I don't think that's going to be hard. But I encourage you to, I gave you links to these in chapter 3, the pip and pop lines and beep study. They're also available, they're on YouTube, those 2 videos. I encourage you to remind yourself in which, like, what the task was in those studies, and in which condition was the task easier, in which condition can you perform the task more quickly. So I'm not going to go over that answer now, but I encourage you to review those studies by going to the YouTube links and making sure that you still remember what we did, or that what the task was. Oh yeah, good one. Okay, so what's the difference between the Cowan and Miller tasks as far as what you're asked to do? Well, let me ask it this way. Which task is harder, the Cowan or the Miller task? Anyone remember?
The Cowan task?
It is the Cowan task. That's usually thought to be a measure of echoic memory, while the Miller task is thought to be a measure of short-term memory. Now, someone tell me, what is it about the Cowan task which makes it harder than the Miller task?
You have to repeat as many digits at the end of a sequence as possible, and it's difficult to start, like you don't know when to start remembering.
Yeah, the key word is you don't know when to start rehearsing. That's really the key word. That's why it's a measure of echoic memory, because you really can't use your rehearsal, which is part of short-term memory. You kind of just wait till the sequence ends, and whatever is echoing in your mind, that's what you're able to say back to the researcher in the Cowan task. More of a measure of echoic memory, while the Miller task is more of a measure of short-term memory. In the Cowan task, you don't know when the end of the sequence is going to occur, which makes it so you can't use rehearsal. A lot of the stuff we went over today, so I feel like it's fresh in your mind, so we don't need to talk about it too much. Oh, the Brown-Peterson task, I'm not going to ask you about. We didn't end up covering that today. So you can cross this one out. We didn't do Brown-Peterson task. Yeah, everything else we went over today. I'll probably ask a question about the mismatch negativity. I'm trying to think what I would ask. Let's just go to the slide real quick. Mismatch negativity. That's chapter 4. Here we go. Okay, so let's start with it. Maybe I'd ask a true or false question about this. So true or false, the data shown here suggests that the duration of echoic memory is less than 1 second. I'll just tell you it's false. The important question is why, though. And so for this type of question, I'd probably do something like 4 choices, 2 of them are true, 2 of them are false, and then each choice has an explanation for why. And I'm trying to think how we could talk about this. Well, okay, so yeah, first, does anyone remember, you get this negativity and the mismatch negativity response. What is the deviant? Does anyone remember what is the deviant in the mismatch negativity response? What is the deviant? You remember the example of that I gave? It's so no one's saying anything. So it's if, like I said, I know I said this and it's in the videos. Ba 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 da. Ba 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 ba. So I say the same thing over and over and over again. That's the standard. But then if I say da all of a sudden, that's the deviant. The theory about this is that you get a big negativity when there's a mismatch. when the thing that I say is different compared to the thing that I just said right before. In echoic memory, I kind of naturally compare those things. And if my echoic memory has two competing signals, the ba plus the da, and they're in there at the same time, then it produces this negativity in the neural response. And you get the difference between these two, the red and the blue waves. You get a difference between these two waves here and here and here. But you notice that starting about 6 seconds, this is the inner stimulus interval. By the way, what is the inner stimulus interval? I know I said that. I'm not going to give this away. What is the inner stimulus interval? Like, what do I mean by inner stimulus interval? No one knows. The inner stimulus interval is the amount of time between each subsequent stimulus. So slow inner stimulus interval is like ba, 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 ba. That's slow. Fast would be ba, 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 ba. Remember, echoic memory has a decay, and we want to know how long that decay rate is. And in order to get the mismatch negativity response, you have to have the mismatch in echoic memory. And so you notice that the difference, there's no difference between the red and blue lines here, which means that we're not getting a significant mismatch negativity. By definition, you get a significant mismatch negativity response when the red and blue lines are separated. We get the separation here because of the mismatch. Our brain is detecting the mismatch here in echoic memory. Our brain is detecting the mismatch here because of echoic memory. Our brain is detecting the mismatch here because of echoic memory. But starting at around a 6-second inner stimulus interval, our brain no longer detects the mismatch. And that's evident because the blue and red lines are not separated right here, or the separation is really, really, really small, almost negligible. This is the mismatch negativity right here, these dips. And when the blue and red lines are separated there, that means our brain is able to detect the mismatch. Our brain doesn't detect the mismatch anymore after 6 seconds. At least it doesn't detect it in echoic memory, because echoic memory has decay. And what these data suggest is that the duration of echoic memory is at least 3 seconds long, because we still see evidence of the mismatch negativity after a 3-second inner stimulus interval. But at 6 seconds, there is no evidence of the mismatch negativity, which suggests that the duration of echoic memory is at least 3 seconds. All right, so I think I'm done unless you guys have questions.
Is there going to be like a time limit for how long we can take the test?
Yeah, I'll probably give you guys an hour. People with accommodations will get time and a half if they have time in that accommodation. So yeah, I'll give you guys an hour. There'll be like 30 or 40 questions. Anything else?
Is it during normal class time or anytime on?
Yeah, I mentioned this at the beginning of class. I'm gonna start it where you can. I'm gonna start it where you can. It'll start during regular class time, but I'll probably give you like 18 hours, an 18-hour window. So if you can't do it Monday night, you can do it Tuesday morning or Tuesday early afternoon. Cool. Anything else? All right. If you guys do have questions about it, feel free to email me, and we can go over things through email. We can have Zoom office hours, not a problem. Just let me know, and I'll give you more information. I'll send an email to give you finalized information about the test once I made it. I actually haven't made. I have the paper version still. I still have to upload it to Blackboard. So yeah, if no one has questions, you guys can take off. And it looks like the internet's trying to kick us off here. Yeah, go ahead.
Really quick question. So we have 2 questions for the weekly quiz. Do you want us to still do it in groups, or do you prefer that we all answer individually?
I'm definitely okay with groups. If you want me to help you organize groups by using breakout rooms, I'm happy to do that. You can also organize your own Zoom calls, and just whoever's in your group, put all your names on it, and we'll grade them. You'll all get the same grade.
Cool.
So do you want me to help you go do breakout rooms right now, or are there any more questions about the test? Okay. If you want me to help organize your breakout room, stick around. If you want to just make your own Zoom calls with people, then you can leave now. I'll start getting I'm going to turn off the recording here.